Welcome to Dreams and Machines of a Cybernetic Pedagogy and its Demise. As you can tell by the format of this talk, I'm sitting here at home in what has become our new norm, the home office. And one reason to re-record this talk, because this is sort of a second take of it, was mainly due to new information that surfaced. But coincidentally, this updated talk about teaching machines also falls into a time in which we are again talking about teaching via and through machines, whether we improvise through Zoom or are struggling to implement new learning platforms that allow us to get rid of frontal presence. Looking at the stock market price of companies like Chegg, we see that online learning has become a completely new business again, as the coronavirus forces us to adapt to a new situation. So maybe these musings about long gone attempts to implement machine teaching could even tell us something about our current situation. Maybe there are some lessons to be learned from machinic lessons that failed to deliver. The German cybernetic landscape during its heydays from the 1950s to maybe the mid-70s was diverse, and one could even say fractured, but definitely unique in comparison to their American counterparts. Much of this uniqueness stems possibly from its own intellectual independence that traces its own roots back to German thinkers and engineers way before Norbert Wiener on the other side of the Atlantic, and even before he coined the term cybernetics in 1948. One of the prominent figures of this unique landscape was Helmar Frank, our human protagonist for this talk. Looking at Frank and the sources, traces, and artifacts he left, we can see one of these figures that are central but often overlooked when one tries to map intellectual histories. He was a multiplier, a connection point, an amplifier, a nexus. One main achievement of Frank is his role in fueling the German cybernetic discourse as an organizer, a publisher, and a personal connection between the many strands of the German cybernetic topography. Countless collected volumes gathering the major German and often also European cybernetic thinkers of the 60s and 70s bear his name as an editor. Sorry. And one of his publication organs, the famous GRKG, Grundlagenstudien aus Kybernetik und Geisteswissenschaft, served as a regular platform for cybernetic debates in Germany. The other major contribution of Frank to the cybernetic discourse were his own intellectual insertions to German cybernetics, mainly the invention and promotion of a cybernetic pedagogy, the simple idea to apply cybernetic principles to teaching and learning. Countless treatises, books, essays, conference contributions about this and related topics, like the programmed instruction, teaching machines, information theory, teaching algorithms can be found. One major part of Frank's cybernetic pedagogy was the idea to not only restructure teaching methods according to cybernetic principles, but also to change the teaching situation entirely by, or at least partially, replacing human teachers with machines, which he and his colleagues constructed, primarily at the Institut für Kybernetik in Berlin and later then in Paderborn. From a contemporary standpoint, many of those writings Frank produced, his fervor in promoting the idea of a cybernetic pedagogy, and also the machines that he built, they seem amusing, to quote Klaus Pias from a 2013 article on the history of teaching machines. And this present day amusement is maybe partly owed to the obvious failure of Frank's ideas. Despite heavily lobbying and even a very huge industry support from German computer heavyweights like Nixdorf and Siemens, Frank's dreams of actually implementing a cybernetic pedagogy never extended beyond some isolated experiments that, in essence, were rather quickly sacked. And another part of this contemporary amusement we might feel is the look of the machines. The machines that Frank propagated. To modern eyes, to our eyes, they simply ooze historicity and maybe even a little bit of a funky DIY look. And they often sport acronymic names like the Baccalaureus. Frank was an enthusiastic European, but also highly skeptic of the beginning Anglophonization, especially in the emerging electronic industry of his time. And therefore he insisted on German or European names for his machines, as you can see. And the ones past 40 listening to me right now might even connect these images of machines to personal experiences in dilapidated language labs in high school, in German high schools, filled with malfunctioning tape machines, smelly vinyl headphones, broken buttons, and overcharged teachers who were as reluctant to use this obsolete technology as we were as students. But these machines, the machines that you actually see here, were the actual tangible products of Frank's dreams of a cybernetic pedagogy. They were, so to speak, the implemented thoughts, to use a term that has been floating around between some of us in this lecture series, and that we still keep on using. So what we are faced with when we look at Frank's machines on the one hand, and his prolific and successful discourse contributing writing on the other hand, might be a perfect example of what this entire lecture series is about. It's about a friction occurring when cybernetic systems or thinking is actually implemented or materialized. And maybe you allow me to take a closer look at Frank's machines as an example of such a friction. Or word the question differently. Why did these machines fail, and why is there such an imbalance between the theory, namely his writing, and the extent of his writing, and the practice, building the machines, using them in school, improving them, and so on? So why is there this imbalance? For a start, I would simply like you all to take a look at some aspects of his biography. As you can see, Frank is born in 1933. This simple date will already allow us to situate him within a larger cybernetic history. If we look at some birth dates of cyberneticists, Wiener is like 1894, Schmidt also 1894, von Neumann 1903, Bateson 1904, Küpfmüller 1897, Georg Claus 1912, Karl Steinbuch 1917. So we can see that Frank is significantly younger. So when Wiener coins the term cybernetics, Frank is only 15 years old. As you can see, Frank studies at the Technische Hochschule Stuttgart and spends 56 and 57 in Paris, where he meets, recommended by Max Bense, Abraham Moltz and Louis Couffignal. And they both introduce him to the very idea of cybernetics in the first place. So you can see as late as 56, 57, that's his first contact point with cybernetics. And in 59, he writes his doctoral thesis about informational aesthetics under the supervision of Max Bense. So as we can see, Frank is a latecomer to the cybernetic game. He's maybe we can call it a second generation cybernetician who is already trained by people who have already laid out cybernetic ideas. After a brief stint as a high school teacher, Karl Steinbuch, the German cyberneticist, drafts Frank into his machine learning research group at the Technische Hochschule Karlsruhe. Again, Frank is under the wing of another cybernetician, and in this case, the one who will become probably the most prominent voice of German cybernetics later on, Karl Steinbuch. In '62, Frank publishes the first volume of Kybernetische Grundlagen der Pädagogik. That will become the standard volume on cybernetic pedagogy. And just 1 year later, he is appointed professor for information science. Later, that's renominated into cybernetics at the Pedagogic University in Berlin, where he also establishes the Institute for Cybernetic for the first time. And in the same year, he's also instrumental in the establishment and organization of the yearly symposium in Nürtingen for teaching machines. And after 6 years of him working in Berlin, the FEOL, one of these German acronyms, simply a research and development institute for objectified learning and teaching methods, is established in Paderborn. And Frank is made one of the directors. And in 1972, the University of Paderborn is established as a full-scale university. And Frank is made a full professor for cybernetic pedagogy there. But now, after looking at our human protagonist, let's start to look at the machinic actors in our story. But unluckily, we need to deal with a people story again first. In 1960s Germany, the country is plagued by what a sociologist called Georg Picht would publicly call a Bildungskatastrophe, an educational catastrophe. And that is nothing new, and that's also nothing particularly German. That is rather something Western. Because starting in the 1950s in the USA and other Western countries like West Germany, they all start to realize that the overall level of education in their respective societies is too low for a future that has to be built on technology and knowledge. Among other things, the famous Sputnik shock sparks new levels of worldwide educational and technological competition. So in order to keep up with the Soviet Union, the West sees that they need to up their game, and they also need to up their game educationally. And just to give you some numbers, in 1945, so just after the war, the average rate of college level education is only 8% in the German population. And the rather rigid, hierarchical, and socially stratified German education system is seen as more and more problematic. And the rising birth rates in Germany starting from 1955 are pointing to a future crisis as well. So this is seen in the numbers, and they need to come up with ideas. And one of these ideas, one of these answers of Germany are large-scale reforms and the establishment of new schools and universities. Subsequently, after building and establishment all of these new schools and universities, they found out that they simply have a shortage of teachers, of university teachers, of school teachers. And there's also subsequently a thirst for new methods in teaching that might provide some answers to the general problem of that educational catastrophe. And within this, and it's really important that this, to explain this climate. So within this reform-friendly climate, the ideas of Frank to simply replace partly human teachers with machines, these ideas sound rather promising to a society that is facing such a catastrophe. And that is also why he gets all of his appointments. He is, by the way, one of the youngest professors ever to be appointed for a full professorship when he gets appointed at Pedagogische Hochschule Berlin in '63. The problem is, as often with universities, he's left penniless. So the university is giving him his position, is giving him some staff positions, but not that much more. So there are simply no research funds for his work, and it takes him until '64, so 1 year later, to gather funds for staff, materials, and even rooms for his lab. The initial funding for 4, later 6 staff members is coming from the university, as I said. And he also gets a little bit of additional seed money, but really not that much. But he's also awarded money from Karl Steinbuch's Institute at Karlsruhe, so his former mentor, so to speak. He's also getting money from the Deutsche Bundespost, as well as the Konrad Zuse AG. The Konrad Zuse AG being one of the German computer building companies at that time. And until 1970, he's able to grow his institute by 100% almost every year. And in 1969, so only 5 years later, he has 62 employees, of which only 9 are paid for by the university. The staggering rest is financed through third-party funds from research foundations like the DFG, Volkswagen Stiftung, research grants, but also to a large degree, and that's important, by industry money. And most often these are German computer manufacturers like the aforementioned SUSE, but also Siemens and Nixdorf. But, and that's also important, also manufacturers of teaching machines. So it's not like he invented the teaching machine, but the idea of teaching with machines is, has been around for quite a while, and they are already actors in this field. And they like the idea that he's propagating, and of course they are thinking about making a profit from it by simply supporting him. So maybe the idea was that he's simply going to use their machine, he's going to advertise for their machines. And these were companies like Sintra, a French company, IG Telefunken, and others. Interestingly, he also gets money from a German consulting company called Quickborner Team and their publisher. They have an own in-house publishing house called Schnelle. And they are very important for the cybernetic discourse because they've published many of the cybernetic works of the West German cyberneticists. Yeah. But exactly this industry money is what needs a closer look and some speculation. One potential reason behind this lavish industry funding is fairly obvious. Frank's research seemed highly innovative and promised a solution for a politically recognized crisis, the aforementioned education catastrophe of the 60s. By funding Frank's research into teaching machines and instructional technology, the German computer industry and others most likely tried to get into a potentially lucrative market fueled by state funds. So looking at the educational catastrophe, the idea is that somehow this needs to be resolved, and maybe it's going to be resolved by teaching machines, meaning that every school, every university in Germany needs to buy this machinery, which will create a huge market. And in that case, one wants to be in that market. So if Frank's machines were incorporating technology from the likes of SUSE, Nixdorf, Siemens, and so on, this could eventually generate profit. And indeed, many of the machines that Frank's group developed utilized especially components from Nixdorf. Okay, and now finally some machines. The overwhelming majority of machines built by Frank and his group were interestingly developed in Berlin and not in Paderborn. And often it's hard to actually find images or machines themselves. Sometimes that also proved to be rather puzzling when we here at the HU, we went through Helmar Frank's estate and we expected to find a treasure trove of machines, of actual machines that we could take a look at, but there was nothing left, only writings, no machines at all, or very, very, very little. So what you will see here is what I could find. The most consistently used and also mentioned system is the Baccalaureus. Because it is a modular system, it is hard to show in its entirety, but this diagram will give you an idea. So as you can see, the Baccalaureus is something like a glorified modular controllable audiovisual presentation system with an image projection system and an audio device that are connected. Material is played for the students, so film, photos are shown, a tape is played, whatever. Then questions are posed and the students can enter their answers through individual answer terminals like this here. And the answer terminal allows the student to enter a very limited amount of predetermined answering choices. Most often it's multiple choice. So it's like you've got 4 different possibilities to answer, or you can answer yes or no. And this logic, the logic of this machine, or the logic that's implemented into this machine, is what you will find in many, many, many other examples of these teaching machines developed by Frank and his peers. So this is truly the operative basis of his cybernetic pedagogy. To give an example from Frank's writings about the questions and the processing of the question. This is just one question and the answer possibilities. a snapshot out of a larger teaching algorithm. And in this case, as you can see, about geography. And here I'll give you my translated and simplified version as a flowchart. Yeah. So what you can see here, the question is, what is the capital of the United States? You can answer New York, Brasilia, Washington, or San Francisco. As you can see, when you answer San Francisco, you're told that your answer is wrong. If you answer New York, you're also told that you're wrong. In case that you're told that you're wrong, you can see indicated by the arrows, that it goes back to the question. So it goes back to the question until you finally answer correctly. The funky thing here is that when you enter Brasilia, the capital of Brazil, it mentions that is also correct, but prompts you to answer the question again. That's a historic side note. In the 1960s, Brazil was were still the United States of Brazil. So Brasilia here is a sort of correct answer, but of course, it hints at, it wants you to answer Washington. And then you can see Washington is correct, and then you'll get the next question. Okay, so this is just one question out of a larger teaching algorithm. And these teaching algorithms can, of course, get complicated rather quickly. If you attempt to map them out schematically in a diagram as a whole, you will see how complicated that gets, because here is a simple one from Frank's writing. Okay. The machines built by Frank and his team were mechanisms to implement these algorithms in order to let them be run by students, by answering the questions, by pressing the buttons. And that allows for an individualized learning process. Okay, and now for another machine. The next example is no exception. In 1964, the German public research grant organization DFG funds the development of a machine christened the Iterator, that you can see here. Yes, it is basically a glorified typewriter. So the Iterator was a singular user system developed and built by Neubert in 1967. And it featured, as you can see, an electric typewriter as a terminal. It also features a magnetic core data storage, a tape player, and a punch card reader and punch. The student enters his answer posed by an audio tape or something that he reads in print, and he has to type in the answer. And the correctness of this answer was measured by a wrong counter. Okay, next machine, slightly more advanced. Here you see the Geromat. It's hard to speak of the Geromat because it's several iterations of the same machine, the same logic. It receives its first funding through the Stiftung Volkswagenwerk in '64 and is subsequently developed between '64 and '66 in Berlin. So this is in essence just a more capable baccalaureus system as explained before. Especially the answer terminal was expanded, as you can see. But what's interesting is that the Geromat is also able to administer group discussions in which a group of students had to discuss the answer once a certain number of students from the group gave a wrong answer. And then you have to sort of settle on one answer, and then you enter that answer as a group. Okay. This Geromat goes through several design stages from the pictured prototype, the Geromat 1, a Geromat 2, of which I can only present you this image here. You can only see the people working on it, not really the machine, unluckily. And then we've got the final Geromat 3, Geromat 3. And in this final configuration, it features an audio tape, a TV screen, 5 answer buttons, 8 visual fields in which you can display visual information aside from the TV screen, and a microphone for these group discussions. And here's a schema of its components and their interactions. Okay. And as you can see, this thing is clearly more advanced than the simple iterator. The Geromat offers a more complex and convincing system, and at least several demonstration programs were developed for it. So it was really hard to find actual teaching programs for this. And it really looks like it never went beyond an extended prototype stage. So all of the stuff that we could find was simply demo material. But there is an interesting side story to the Geromat because it had some interesting traction. In 64-65, under the supervision of Thomas Maldonado, back then teacher and head of the famous Post-Bauhaus Hochschule für Gestaltung in Ulm, a student team in his class designed a case and an interface for a teaching machine that is clearly based on the Geromat 3. Let me show you what they came up with. So as you can see, they are not really rebuilding the innards of the Geromat. They are just building a new case and interface for it. But it's of course interesting to see that there is this connection, the connection between Frank, cybernetic ideas, Maldonado, Hochschule für Gestaltung, Ulm. And this connection is, let's call it, under-researched. So there are still research projects looming for other people that might prove rather fruitful. At least for now, the only direct link that I could find is that artist and designer Kurt Alsleben taught at Ulm, at Hochschule für Gestaltung. And he is someone who integrated cybernetic ideas into his art. And he's also a close collaborator of the Schnelle brothers. I've already mentioned them before. And they were supporters of Frank and the general German cybernetic scene. So I assume that maybe von Alsleben introduced these teaching machines at HFG Ulm, and then Maldonado thought that that might be a brilliant student project. Maybe also the students themselves came up with the idea. Yeah. Okay. Next machine. The RoBIMAT. The RoBIMAT, again, is nothing else than a larger scale version of the Baccalaureus system that was developed in '64 and that got continuously enlarged. There are some records of what looks like a small serial production starting in 1970. And the Baccalaureus in this RoBIMAT configuration also saw some limited use in several school trials. The RoBIMAT features up to 64 of the simple Baccalaureus answering units that you already know by now, and also, and finally, a computer as a controlling unit. The controlling unit in our example of the RoBIMAT is a Nixdorf 820. This is what it looks like. And as you can see, the Nixdorf 820, or you rather cannot see it, it's a Harvard architecture computer that was actually built 40,000 times between 64 and 79. So it's an industry standard. It's an industry standard manufactured by Nixdorf. It features a magnetic core memory and either a punch card data carrier system and or later on a data set. But these technical details of the Nixdorf computer play no real role for the functioning of the Baccalaureus system in his RoBIMAT configuration or otherwise. You could simply connect a multitude of computer systems to it if you wanted to. And the fact that Frank specifically mentions a Nixdorf 820 is probably simply exemplifies the close economic relations between Frank and the Nixdorf company. What's interesting is that the use of a computer in this configuration as a controlling unit makes this RoBIMAT configuration of the Baccalaureus the first truly computerized learning machine of the Frank group. So here, a machine operating on algorithms, a computer, is used for the first time to implement teaching algorithms. So cybernetic thinking and a machine built on cybernetic thinking intertwine here. This RoBIMAT with the Nixdorf computer behind it was also used in the large-scale ACLU school trials at the Planck Oberschule in Berlin-Wedding starting in 1968. Here you can see the documentation about it, an entire book published. The results of these school trials were mixed. So it simply proved that computer-aided cybernetic pedagogy can be used in actual school settings, but the necessary efforts, and by efforts I mean both financial efforts, but also in regards to staff were extensive, and that proved a problem. So it's simply really expensive, and you needed trained people, and the idea was, will we ever have enough money for all the German schools to implement that? And then also we need to hire all of these specialists that can actually implement it. Still, this RoBIMAT seems to be the closest Frank and his associates ever got to a serial production and implementation of teaching machines. There are actual sales brochures for the RoBIMAT, like this one here. And as you can see, they feature a larger student terminal like this. And there's also a rather professionally produced mobile suitcase version. You can see an image with smaller student terminals. And I have this image from the Nixdorf archives. So again, it seems to be manufactured by Nixdorf, and it looks so much more professional than the prototype versions that Frank did. So maybe that was the idea, to then have it manufactured by Nixdorf. But then again, I mean, the Nixdorf archive doesn't have any records on it aside from this image here. Okay, next machine. The ETSI, ETSI for Einzeltastensperrung. This is simply a system module for the baccalaureate system, and it's developed in '68. And it's kind of ridiculous, but, and I'm going to tell you about how interesting and ridiculous it is later on. But despite being ridiculous, it was still showcased at the Didakta Education Fair in 1970. It features up to 3 typewriters as student terminals. And again, they're using one of these Nixdorf 820 as a central unit. Here again, the system requires the student to type in the answer to a question posed. But the system automatically locks all the keys. It locks all the keys that are not needed. So simply by locking all the keys, it prevents you from typing in a correct answer, forcing you to answer correctly. Okay, next one. The 1965 Didact, this here, was a development for AEG Telefunken, one of these third-party donors to Frank and his efforts. It features an audiovisual display and allows the students, again, to press 4 answer keys. The technology appears almost like an encased single-user baccalaureate system. So as you can see, again, the general idea is never changed. They are just building new machines around it. The terminal itself has a striking resemblance to a BASF Telefunken machine called System 5100 that you can see here. And we could speculate, and I think it's a rather valid speculation, that the System 5100 is just a simple further development of the Didact. Okay. The high point of these learning machines pioneered by Frank's group was surely the Educator that you can see here. Developed in '61 in conjunction with Berlin computer manufacturer Wagner Computer, it allowed up to 16 students individual instruction, even with individually different programs. Because each terminal is equipped with its own audiovisual output system through a slide projector, a tape machine, and a monitor. And the interesting point about this is that they are not using a large computer like the Nixdorf 820, but the central unit here to record all the students' answers and to run the machines was a Wagner computer WAC 12 that you can see here. And the entire setup also allows to track the students' use time and also the path that the students use to get to the solution. In contrast to large computing systems used so far for learning machines, this WAC 12 was truly a compact and affordable solution. So that solved one of these funding problems. According to Uwe Lehnert, the developer of that educator, and Frank's technical right-hand man, the educator had already created interest by larger institutions of higher learning, as far as I remember, in Belgium. But unluckily, the Wagner Computer Company experienced major financial troubles exactly during that time. And that led subsequently to the owner, Günther Wagner, being arrested in '74 on financial charges. He was later acquitted. I think he sat in prison for, I don't know, a year or maybe even 2 years. So huge trial, several allegations. Anyway, but he was acquitted later. The problem is, of course, that his computer company went bankrupt in the meantime. So here we have finally a system that seems to work. It utilizes a readily available computer. They have clients for it, larger institutional clients, but the moment they want to close the deal, simply their computer company or the company providing the computers that run these systems goes bankrupt. Yeah. Case of bad timing. Okay, so generally, in conclusion, we see that all of these machines were developed by Frank and his employees in Berlin and not in Paderborn. And although the move to Paderborn, which is also a move closer to Nixdorf, one of his financiers, sounds beneficial, and also because Frank is appointed as full professor at the university and at the finally university with full rights to grant PhDs, in contrast to the Pedagogische Hochschule Berlin. So you would expect something like a major boost in his activities of building the machines, activities of actually implementing them in schools, and so on and so forth. Interestingly, the opposite seems true. When it actually comes to implementing his theories, Berlin was clearly more productive. And while in Paderborn, he shifts his work to more theoretical work and to lobbying and trying to get his machines into schools. So why did the machines and maybe also cybernetic pedagogy fail in the end? Looking at the sources, I can only offer educated speculations. And unluckily in this format, I cannot discuss them with you later on. Sorry. Okay, speculation number 1. The competition and bad marketing. Frank was by no means the only one developing teaching and instructional machines, and the fact that he was awarded contracts to develop machines for other manufacturers like IG Telefunken or Wagner Computer only attests to a vibrant economical interest in teaching machines. In his own 1971 Introduction to Cybernetic Pedagogy, this here, he himself describes a plethora of teaching machines that are not developed by his own group, but also by private companies like the humble page scrolling device Promenta Boy by Braun Boveri, that you can see here, the French MITSI 2023, that you can see here, the American Auto Tutor, that you can see here, developed by Crowder, and many more. So they all get an honorable mention. It's not like he simply glosses over them and promotes his own machines. No, he really gives them an honorable mention. So like, oh, that all can be used. On the other hand, Frank and his group were clearly not an economically disinterested group. In his estate, we found actually a couple of documents pointing to a company set up specifically to market the Baccalaureus in its Robimat configuration. So, and this company was called the Euro Lehrtechnik GmbH. You see their logo. Again, one of these Frank acronyms. It's an acronym for elektronische Unterrichtsrationalisierungs- und objektivierte Lehrtechnik. This company was already established in Berlin and was then apparently moved with Frank to Paderborn. So there are two addresses, one in Berlin and one later on in Paderborn. The only thing left of this company, the only thing tangibly left in Frank's estate of that company, however, are two sales brochures for the Robimat 2 system. And here I'll give you an image of the first one of these sales brochures. This first one is, as you can see, rather pitiful to look at, and it dates back to Frank's time in Berlin. As you can see, it's a hastily hand-typed, Xeroxed and stapled folder, black and white, that contains a hand-drawn Xerox diagram of the system. Even for 1960 standards, it looks laughable as a sales brochure. Hard to imagine that he would have ever sold anything with that brochure. Okay, the later iteration of that brochure dates back to Frank's time in Paderborn. Here it is. As you can see, it looks slightly better. At least it's professionally printed, but it's still far from catchy. So maybe we can speculate, among other things, a simple lack of marketing skills might have led to the demise of Frank's teaching machines. Maybe. But what also might have hindered a further economic success are the staggering costs of Frank's system. The Robimat system could easily cost up to 80,000 Deutschmarks. And that's a sizable sum considering that the idea was to sell these systems to schools, meaning that each school needs one of these systems. So each school needs to cough up 80,000 Deutschmark. And of course, that's not incorporating the money that you need to set it up, to have people to instruct local teachers, training, spare parts, and so on and so forth. So it gets expensive rather quickly. Okay, so maybe bad marketing and maybe it was just too expensive. But then we could ask ourselves, okay, if Frank didn't deliver with his machines, what about the other machines, the machines that he mentions, but that he didn't build in the first place? So what about the machines not marketed by Frank, but developed by Frank and produced and sold by others? After all, Frank was funded by companies like AEG Telefon, who built the system 5000, that you can see here again, or Sintra and their MITSI system that you can see here. And as you can see here, they are way better of printing sales brochures. So as it turns out, their sales brochures might have looked better than those produced for Frank's machines, but all the companies mentioned, so all the other ones as well, were plagued by a common problem, apparently. In 1973, Frank himself complains about the general problem of producing teaching machines at scale. During the heydays of cybernetic pedagogy, Frank and his group, Nixdorf, Sintra, and all of the others, seemed to fail to deliver past the prototype stage. The potential demand for teaching machines was met with no real supply. And as if to blame his own employees, Frank complains about the developers of machines developed under his wing, like the Robimat and Giromat. Because there are some words that all too often the developers of these machines, so actually his own people, that they would keep improvising these systems. And by, or not improvising, they would keep improving these systems. They kept on working on these systems, working on these systems, working on these systems. But they never really focused on creating stable products. And apparently the buyers were fairly confused. So the buyers were presented with something, and then whatever, a couple of months later, they get something completely different that does different things. So like, no, that's not what we ordered. We ordered something completely, completely different. Yeah, so that is something that he himself complains about. Okay, next speculation. The political climate and, quote, the new left. In 1971, the German federal government instituted a Commission for Economic and Societal Change. That was actually a huge commission with a lot of funds, and they contracted out research projects, large research contracts. And Frank and his group were, unsurprisingly, contracted for a project on new education media and technologies in schools and in vocational training. So, makes sense. Frank has already this group. He has sort of an institutional university sort of cloud and backing. He has all of these things written. So he's one of the major experts on that. So he gets that research project. Okay, the result of that Frank research project is this book. This book here that came out in '75. And that's a report on what they did. This report reads, unsurprisingly, like a simple reiteration of ideas and concepts already floated and published by Frank in many other essays years before. So he simply explains the concept of cybernetic pedagogy and offers it as a solution for the current educational crisis. For our speculations, however, there is one remarkable chapter, because there's one chapter on what he calls the reaction of the new left, the reaction of the new left to cybernetic pedagogy. And in this chapter, Frank, who is a long-standing member of the German Liberal Party, which is a little bit more libertarian than the English term liberal implies. Maybe it's even neoliberal. So in this chapter, he defends his ideas of a cybernetic pedagogy against what he calls the new left and their quote unquote reactionary and technophobic attacks against his ideas. According to Frank, these attacks paint his school of thought as technocratic, capitalist, and not egalitarian enough. This new left he speaks about can easily be identified as the so-called generation of '68 that dominated the university discourse beginning in the late mid to late '60s. Judging by the fact that he sees himself inclined to dedicate an entire chapter about these attacks, seems to suggest that indeed the new political mainstream turned against him and his projects. But also important, the same report comes with an appendix. This appendix is an additional review. It's a review of that research project. And also that review was again contracted out. And this is a review written by Felix von Kube. Felix von Kube is important because he's a renowned pedagogue in Germany. He's also a major proponent of the idea of cybernetic pedagogy, but he's not necessarily a friend of Frank's individual ideas within that cybernetic pedagogy. And his review is overall friendly and positive, and it sides with Frank in many aspects, but it also highlights some rather problematic claims made by Frank. One of these claims is an alleged 70% efficiency increase in teaching when teaching machines are used. And von Kube asks, like, well, how do you calculate that? Where's the proof for that? So one of these grandiose claims is debunked in that review. Additionally, von Kuber highlights the high cost of using computer systems in the classroom. We've already talked about that, underscoring the aforementioned economic argument against Frank. So maybe we can sum up some of the potential reasons for the failure to implement Frank's teaching machines and his ideas. As you can see here. First, the inability of all actors to develop market-ready solutions. The high costs. The claimed benefits of efficiency were never proven or even doubted. Then there were simple external problems like the Wagner bankruptcy that we talked about. And then we've got the changing political climate. Additionally, we might speculate whether the whole concept of cybernetics, and with it also the cybernetic pedagogy, was past its peak. And maybe in 1975, the time of the publication of Frank's mentioned study, the general tide had turned against cybernetics as a whole. As Philipp Aumann rightly remarks, in the mid-1970s, cybernetics had lost its traction. Many of the cybernetic grandiose promises, like Frank's, for example, but there were also other grandiose promises, many of these promises had been humbled. The novelty of the concepts was overextended, and cybernetics as a whole faded into obscurity. Okay, but the bigger picture, the dispositif and a cybernetic pedagogy without a cybernetic theory. As Klaus Pias has pointed out in 2013, it is easy to locate Frank's cybernetic pedagogy and his teaching machines in a bigger picture of teaching machines and what could be called an algorithmicization of teaching and instruction. Frank is by no means original in what he attempts in the 60s and 70s. And sparing you a complete historical rundown, I will simply focus on Frank's direct predecessors and some parallels. The most important one is, of course, Burroughs Frederick Skinner, the psychologist and behaviorist. Skinner pioneered a teaching method he called programmed learning, which used very simple teaching algorithms. And Frank even references Skinner in his publications. This, for example, is the illustration of a Skinner teaching algorithm taken from a publication by Frank. Skinner, however, was also a pioneer of teaching machines that resulted in devices like this here, the DIDAC 501, manufactured between 1959 and 1960 by the Riem Caliphone Corporation, just a few years before Frank's team starts to develop their machines in Berlin. Conceptually closer to Frank is US Air Force psychologist Norman Crowder. He developed Skinner's ideas of programmed learning further, and his teaching algorithms were far more complex and can be easily identified as the foundation of Frank's ideas. And again, we can find Crowder featured in Frank's publication on cybernetic pedagogy. This illustration of a Crowder algorithm is again straight from a book of Frank. And again, also Crowder was building teaching machines to implement his teaching conceptions like the AutoTutor Mark II, that you can see here. Very little information can be found on the AutoTutor, but it was probably developed in the late 50s and was commercially marketed, used in American schools, and it was even available in Germany. German educational publisher Westermann, fairly well known, still in business, was offering at least 50 different programs for this AutoTutor by Crowder in Germany. So this was on the market, and this was apparently on the market in numbers that facilitated an educational publisher like Westermann to print 50 different programs for it. Interestingly, neither Skinner nor Crowder mention cybernetics as a concept in their ideas. So what they're doing is something that runs parallel to Frank, that can be seen maybe as a predecessor, maybe as a parallel to Frank, but there is, so to speak, no cybernetics in it, or not the term cybernetics. That's important. And maybe that's just one indication that you do not need an elaborate cybernetic theory, nor the label cybernetics for commercially successful teaching machines in the 50s, 60s, 70s. And the same goes for all the other machines we and Frank mention. The Promenta Boy by Braun-Boveri, the BASF AEG Telefunken machines, the MITSI, and so on. Even at the yearly symposium in Nürtingen that Frank is instrumental in organizing, the majority of contributions and case studies do not even mention the term cybernetics, but rather use terms like teaching algorithm or programmed instruction or programmed learning. Thus, looking at the machinic and intellectual landscape, Frank appears as just one particular dot on a map, one point in a whole landscape that is concerned with the idea to model teaching algorithmically and to build machines for it. A whole dispositif which proves successful both discursively, economically, and policy-wise internationally in the 1960s. Frank seems to be a theoretically loud voice, but his ideas are not really picked up. And other machines and implementations of the dispositif of programmed learning are way more successful than his. The elephant in the room is, what you see here, the language lab movement. Or as we in Germany call it, the Sprachlabor. Independently of Frank, the language labs and their machines are actually spreading into schools, in almost all the schools. And they have their brief moment of glory in the 1970s in Germany and other Western countries. Here, cybernetic pedagogy, without using the term or overarching concept of cybernetics, is actually implemented. Algorithmic instruction is built into machines, marketed successfully, and ends up in almost every German high school. And even, that will tell you something about my age, and even I have vivid memories of the last wrecks of this technology, gathering dust in the basement of my high school, semi-defunct, and used on us as students maybe twice with dubious outcomes. But of course, this is only a German perspective and a historical German perspective. Internationally, language lab learning is still thriving. And the moment that you have to take a test for an American college, like a GMAT, a TOEFL, GRE, whatever, you're faced with the hard truth of teaching and testing machines which work based on that language lab paradigm. So it's still there. It's still out there. It's still thriving. Yeah, again, without Frank and his theory. What we see here again seems to be another iteration of Sibylle Krämer's famous remark about cybernetics, according to which the victory of cybernetics becomes apparent in its vanishing. And maybe it's also a reminder to look for actual implementations, the quiet but successful ones, the second row of engineers and companies, to look at systems that actually operated in companies and classrooms and why they did. But one then is the value of looking at figures like Frank that failed. In case of his machines, we could, the value could be to see what kind of thinking produces which machine, and also why it produces machines that are not successful. And of course, one other value could be just historic completeness. But I think Frank proves instructive in a completely different way. Maybe his slightly sensationalist promises and claims prove to be actually a hindrance in implementing his ideas into machines and classrooms. But maybe because he was such a voice instructing us, but maybe he is a voice instructing us to look for a general cyberneticity of teaching machines. Maybe we can use him and his claims to dig deeper into the not made claims of the ones who built teaching machines without such an elaborate theory. And if we do that, so if we use him as sort of a theoretical toolbox to look into other teaching machines that don't come with a theory, and maybe then what's exposed is that all the other teaching machines are actually using cybernetic paradigms, whether they know it or not, whether they knew it or not, whether they wanted it or not. Cybernetics as a whole thus proves to be a schema that exposes itself to be deeply hidden within the dispositif, a dispositif that's still at work. It might have evacuated from some classrooms, but just open any language learning app on your smartphone and you're in it right again, following teaching algorithms and feedback loops and reperforming, but not necessarily Helmar Frank's cybernetic pedagogy. Thank you.